Problem 5 from the 2025 AP Calc AB free response set. Non-calculator question here says we've got two particles, h and j, moving along the x-axis. On the interval 0 to 5, position of particle h at time t is given by x of t, x sub h of t. And the velocity of particle j at time t is given by v sub j of t. So what you have to pay attention to throughout this problem is the fact that you have access to a position function for h rather, and you have a velocity function for j. Pay attention to what each part of the problem is asking you to reference. In this case, part A is asking us for the velocity of particle h at time 1. Show the work that leads to your answer. So if this is the position function for particle h, I would take the derivative of that position function, and you see I've done that using a chain rule, so I get e to the same inner function and then times the derivative of the inner function to establish my velocity function for h, and then I need to evaluate that at time 1. So when I put 1 in place of all of the t's, this right here would receive full credit. It does simplify a little bit. You don't have to do it on the AP exam. It turns into this. But this right here would be A-OK on the AP exam. Part B asks us to figure out the open intervals on the interval 0 to 5 where the particles are moving in opposite directions. Give a reason for your answer. Now I thought, well, the particles are going to be moving in opposite directions when the velocities have different signs. So I need to know when the velocities change from positive to negative for each of these particles on the interval 0 to 5. So what I did is I took my velocity function from back in part A for particle h, and I set that equal to 0. This is already written as multiplication. E to a power is never going to equal 0. 2t minus 4 is going to equal 0 if t is equal to 2. Now the velocity function for particle j is given here. If I set that equal to 0, I can factor it a little bit further than it's presented. 2t times that quantity cubed, where the quantity inside is able to be re-expressed using the formula for a difference of squares. So this tells me that the velocity for particle j is equal to 0 when t is 0, when t is -1, and when t is +1. Now we really only need to worry about +1 because we're supposed to concern ourselves with the interval from 0 to 5. So what I did next is I kind of went with a sign chart here. On the interval 0 to 5, what is the sign of the velocity of particle h? And on the same stretch, 0 to 5, what is the sign of the velocity of particle j? Now what I did is I put the places where these velocities have the potential to change signs, I put those times on this number line across the top here. Now if I pick a value between 0 and 1 for particle h, and I test the sign of the velocity, e to a power is always positive. 2 times 1/2 minus 4, right? 1/2 is obviously between 0 and 1. Gives me a negative. Positive times a negative gives me a negative end result. I'm still going to get a negative end result if I picked a value like 1.5 and put it here. But on the other side of 2, at a value like 3 or 4, this is positive, this is positive. Multiplying the positives together keeps my velocity for particle h positive. Now for particle j, if I pick a value between 0 and 1, like 1/2, putting 1/2 here makes this positive, putting 1/2 here makes this positive, and then putting 1/2 here makes this negative. Negative times a positive is a negative, negative cubed is a negative, negative times a positive, negative velocity for particle j between 0 and 1. Now between 1 and 2 at a value like 1.5, this is positive, this set of parentheses is positive, this set of parentheses is positive. Everything being positive is going to leave everything positive. Same thing happens if I pick a value like 3 or 4, put it in place of all the t's. So check out my sign chart here. Where do I have differing signs? Not from 0 to 1, not from 2 to 5, but on the interval from 1 to 2, the particles are moving in opposite directions due to the sign of their velocities being opposites. Part C says that we know that the derivative of the velocity of particle j at time 2 is positive. Is the speed of particle j increasing, decreasing, or neither at this time? Give a reason for your answer. Now, in order to make conclusions about whether speed is increasing or decreasing, you need to look at whether or not velocity and acceleration are working with one another or if they're working against one another. We know that this right here, the derivative of velocity, is the acceleration of particle j at time 2. Particle j has a positive acceleration at time 2. Now what about particle j's velocity at time 2? Well, if I put 2 in place of these t's, what I end up with for my calculation for the velocity of particle j at this time, I end up with a positive value. Because velocity and acceleration are both positive, because they're working with one another, they have the same sign, I know the speed of particle j is increasing at time 2. If this was positive and velocity was negative, or vice versa, if they have differing signs, they would be working against one another, and our conclusion would be that speed is decreasing. That is not the case here. Final part of this problem says that particle j is at position 7 at time 0. Find the position of particle j at time 2. Show the work that leads to your answer. So at time 0, I know particle j is at position 7. So I'm taking that as my starting position, and I'm adding on how much the position of particle j changes by from the time that I know the position, which is 0, to the time that I want the position, which is 2, by integrating the rate of change of position, which is velocity. Now to do this integral, what I'm going to need to do is actually use a u-substitution. So if I let u equal what's inside that set of parentheses, I end up with du over dt as what I'm going to replace the du over 2t as what I'm going to replace the dt with. That gives me the cancellation of the 2t that's sitting here with the 2t that comes about through the substitution sequence. The big change that has to happen here, if not, there's going to be a big notational penalty in your FRQ scoring. If you're evaluating a definite integral by hand using u-substitution, the instant the differential changes from the original variable, which in this case is t, to the new variable, which is u, your limits of integration also have to go through a transition from the original variable values to the new variable values. This is an easy adjustment to make. The original upper limit was a t value of 2. What is the corresponding value of u? 2 squared minus 1, which is 3. What's the corresponding u value to a t of 0? 0 squared minus 1, which is negative 1. I find the antiderivative of u cubed, which is u to the 4th over 4. I evaluate it at 3. I evaluate it at negative 1. I take a difference. This line right here would receive full credit. If you do try to simplify that a little bit, which again is not required in an AP calculus grading format, so pay attention to your professor, your teacher, as to how they're going to be scoring things. Might have to be simplified to the 27 that you see here, but for the purpose of the AP exam, this line that you see right here would receive full credit.